Another substitution cipher technique is due to Lester Hill, and this was given in 1929. It was given by assistant professor of mathematics at Hunter College at that time. And now let's look at what is this Hill cipher. So in the Hill cipher, this is based on the mathematics of the square matrix. So let me to write here. So we use here the square matrix K and its inverse. So let me to denote the inverse by K inverse. And what we need to get is we have a ciphertext, and for the ciphertext we need to find a function converting that plain text into the ciphertext, and that conversion is done by the multiplication of the plain text with the matrix modulo n for all the p belonging to capital P. And for the reverse process also we can see that P is same as plain text is same as F inverse C, that is same as K inverse multiplied by C modulo n. Now to explain this process, let me to consider an example. So for the illustration, let me to consider the K matrix as 2, 7, 3, 8, and let's consider the plain text as, so the plain text given to us is no answer. So this is the plain text. Now in this case, considering the plain text as the block of 2 letters, so we write here the encrypted message C as the product of the given matrix K, that is 2, 7, 3, 8 multiplied by, then I use the, let me to first also write this as numerical transformation. So the numerically n can be written as 13, O is 14, A is 0, N is 13, S this is 18, W this is 22, E 4 and R is 17. So now writing this 13 and 14 as a column. So let's write 13 and 14 as a column. Then write these two as a column, 0 and 13 of the block 2. Then write 18 and 22. And then write 4 and 17. And we take this as modulo 26. Now do the normal matrix multiplication. So this is same as if I do the normal matrix multiplication. And then I am going to write the congruent modulo 26 if the digit exceeds the 26. So as you can see that the first quantity is 2 multiplied by 13, that is 26, plus 3 multiplied by 14, that is 42, which is equal to 68. And if you look at this 68, this is congruent to 26 multiplied by 2, we got 52. So if I simply subtract 68 minus 16, so this is congruent to 16 modulo 26. So that means as a remainder in terms of the congruence class, here I need to replace the first digit as 16. And similarly follow the next one, that is 21. And following the same way, let me to write down these digits as 24, 16, 7 and 8 modulo 26. So that means the cipher text is, so let's write now the cipher text in the same orders, the same blocks. So we have first written this, we first write this block, then this, and consecutively the last block. So we get 16, 21, 13, 0, 24, 16, 7, 8. And let's then write the corresponding alphabet. For 16 we write Q, this is V, N, A, Y, Q, H, I. So this becomes the cipher text. Now for the deciphering, as I mentioned here, we just need to take K inverse. So we need to find what is the inverse of this matrix and multiply it by the ciphertext digit, and then we can get back to the plain text. Now let's look at the reverse process. So for this, let me to first find what is K inverse. So writing K inverse in the usual manner, I get 14, 11, 17 and 10. And so plain text is K inverse multiplied by C. So this means this is 14, 11, 17, 10. This is multiplied by, now again take two blocks at a time. We already have the digits. So 13 zeros, this and this. So we get this as 16, 21, 13, 0, 24, 16, 7, 8 modulo 26. So this is same as when we again multiply 14 multiplied by 16, 11 multiplied by 21. The product of these quantity becomes as equal to 455, and which is same as congruent to 13 modulo 26. So now that means here I can replace the first position as 13 and the remaining following the same procedure. I get these quantities 14, 13, 22 and 7 modulo 26. So now again corresponding to these write down the alphabet in the same order. So this is same as what is given to us, so that will give us no answer. So this is how we can get the plain text. And now let's taking one more example in terms of the congruences, or I can say simultaneous linear congruence. So here I am going to write this as an application of the congruence, simultaneous linear congruence. So in the simultaneous linear congruence, we will not use the matrix multiplication, rather we will consider the block of 2 individually. So to illustrate this, let's consider this example. And as I mentioned that in the plain text, so let us consider this as the plain text, and in the plain text, whatever be the number of letters, let's consider this as this is P1, P2, and considering these letters into the block of 2. So this is P1, P2, which I am considering in the block of 2, and corresponding to C1 and C2, these are here. So this is CP2 plus D times P2 modulo 26. So in the given problem, we must be knowing what is P1, P2, since that can be read from here. We must also be knowing what is the key or the K matrix. So that is why I say A, B, C, D are also known. So we need to find C. So for the solution of C and D, we have this condition in the congruences that the GCD of AD minus BC with respect to 26. So the GCD of these two integers should be equal to 1 for the solution. Now let's consider the particular data here. So C1, this is congruent to 2P1 plus 3P2 modulo 26. So suppose these are given in terms of the congruences, that following this process, you need to convert a plain text. And I'm also considering the plain text as we need to encrypt by now. So this is the plain text which is given to us. So let's consider this as plain text. Okay. So now in that plain text, you can note down here, these are the block of 2. So that means for the first thing that I need to know what is the digits corresponding to this one. So for B, we know that this is equivalent to 0, 1, and U, we know this is equivalent to 20. So when it is equivalent to 20, I'll now put this into the formula. So this will become 2 times the first plain text, that is P1. So this is 0, 1 plus 3 times the second plain text, that is 20. This is congruent to, so when we multiply, this is 2 plus 60. So this will become 62. 62 is congruent to 10 modulo 26. And similarly, we have 5 times P1. P1 is 0, 1 plus 8 times P2. P2 is 20. So this will become 165, which is further congruent to 0, 9 modulo 26. So now you can see that corresponding to these two, we got the conversion. And the digit which is converted, this is 10 and 9. And corresponding to 10 and 9, I have the alphabet K, and corresponding to this we got J. Now repeat this process for the remaining one. So when we repeat this process, so let us repeat the process for the next block, which in this case become Y and N. So Y is 24 and N is 13. So that means this will become 2 into 24 plus 3 into 13. So this is congruent to 7, congruent to 9 modulo 26. And for the second ciphertext, this is 5 into 24 plus 8 into 13, that is congruent to 16 modulo 26. So we can see that we have now the two digit with us, 9 and 16. So that means now we can write these two will convert into 9 and this will convert into 16. And corresponding to this 9 and 16, here I got J, and for 16 we got Q. And similarly now with the similar repetition of, we see that this plain text O and W, this is converted into Q and M. So this becomes the cipher text. And for the deciphering process, now let us write for the deciphering process. So suppose that we now have been given the text as K, J, J, Q, Q, M, and we know that now corresponding to these we have the digits 0, 9, 16, 16 and 12. And now we want to decipher in the similar manner. So that means here I am going to find P1, which is congruent to 8 times C1 minus 3C2 modulo 26. So I am going to use the same inverse procedure. And for P2, this is same as minus 5 times C1 plus 2 times C2 modulo 26. So we can solve these as a simple equation to find out if we know what is the value for P1, P2. So look at this one. If we know what is C1, C2 in terms of P1, P2, so following the back, we can find the value for P1, P2 in terms of C1, C2. So now repeat the process. We already know this data and we already know what is here, that is 8 minus 3 minus 5 minus 2. So for example, I want to find the first P1 for the first block. So this is 8 times the first quantity is 10 minus 3 times 0, 9. So the second alphabet correspond to 9. and this is congruent to 53, which is further congruent to 0 1 modulo 26. We can see that. And for P2, for the second plain text, we got minus 5 into 10 plus twice of 9. This is congruent to minus 32, which is further congruent to 20 modulo 26. So that means the first two plain text alphabet correspond to 0 1 and this correspond to 20, and 0 1 correspond to, we can see this is B, this is U, and so we follow the similar procedure to find all the other alphabets. So we can get by now. So we can get back to the plain text.